Welcome back to the deep dive. We sift through all that information out there, cut through the noise, and really try to give you the insights you need quickly.
Yeah, and today we're diving into something pretty fascinating. It's this intersection, this merging of generative AI and the good old scientific method and how that's changing education.
Right, AI is everywhere, obviously, but applying it to the scientific method itself, that feels, well, foundational. So our sources today come from a session called Empowering Inquiry, AI and the Scientific Method in Practice.
That's right. It featured Lizelena Iglesias from LAC in New York City and Hawes from Pima Community College, both experts in adult ed and ed tech.
Okay.
And our goal here really is to unpack how AI can practically support each step of scientific inquiry, how it can almost turn the classroom and even teaching itself into like an ongoing experiment.
Okay, let's get into it. So, starting broad, why the scientific method? Especially in adult education. People might think that's more for like high school science. Why is it so central here?
That's a really good question, and the presenters were quite clear on this. They see the scientific method as, and I think this phrase is key, the backbone of all learning.
The backbone of all learning. Wow. Okay.
Yeah, it's not just about memorizing science facts. It's the framework for critical thinking, for problem solving. It helps build learner confidence, and honestly, it helps people make sense of the world reading news, health info, you name it.
And it connects to testing too, I imagine.
Absolutely. For adult learners, especially those maybe working towards equivalency exams, the structure of scientific thinking directly maps onto a lot of test content. So it's a really crucial transferable skill.
Okay, so if it's this vital backbone, what are the actual specific struggles students have with it? Why bring in something like AI?
Well, the sources pointed to some persistent challenges, things like pretty limited problem-solving approaches, weak reading comprehension, especially inference.
Reading between the lines, basically.
Exactly. And a big one in science. Just difficulty interpreting data, charts, graphs. Plus, often they just haven't had explicit instruction on how you actually do science, the practices involved.
Right. That makes the case for needing some kind of support, some tool.
Yeah.
So AI, let's define that quickly. We hear AI constantly. What are we actually talking about here?
So we're mostly focusing on generative AI. That's the kind that creates new stuff, text, images, ideas. Think ChatGPT, Google's Gemini, Claude AI.
The ones everyone's talking about.
Right. But the sources also reminded us AI isn't just those big names. It's kind of baked into lots of things we already use, like Siri or Netflix recommendations, even Google Translate.
And the general idea, the big benefit these tools bring to those student struggles we mentioned.
It goes beyond just finding answers. Think about those issues. Weak comprehension, trouble visualizing concepts. AI can tackle those head on. It can generate different explanations, practice problems, give feedback that's, tailored to where that student actually is.
So it adapts.
Exactly. It adapts. And it can make abstract ideas more tangible, like through virtual labs or simulations. That helps bridge that I just can't picture this gap immediately.
Okay, so it offers sort of rapid feedback and visualization that maybe a textbook or a single explanation can't quite match.
Precisely. It encourages this active cycle of trying something, seeing what happens, adjusting, which is, well, it's the scientific process in action, right?
Yeah, it really is.
Yeah.
Okay, that sets the stage perfectly. Let's get practical. How did the sources show teachers actually using AI step by step through the scientific method?
Right, this is where it gets really interesting. AI tools are becoming almost like research partners. So step one, background research. This is often a huge hurdle, right? Just wading through sources, figuring out what's credible, understanding dense language.
Yeah, that's where that reading comprehension issue really bites.
Totally. And here we see tools like elicit.org pop up. It's an AI research assistant specifically designed to help find and, crucially, summarize scientific studies. Makes them more accessible.
Summarize. Okay, that's useful.
Very. And another one mentioned was cite.ai. This tool analyzes how scientific papers are cited by other papers. Are they supported? Contradicted. It helps gauge credibility and find related evidence quickly.
Okay, so Elicit and Cite.ai sort of cut through the noise and help with that comprehension barrier by summarizing and verifying. They let students jump ahead to the actual thinking part.
That's exactly the idea. Get past the filtering stage. So once you have some background, you need to form a hypothesis or a good question. Here, tools like ChatGPT can be really helpful for just brainstorming, taking vague ideas and sharpening them into something testable.
Like a brainstorming partner.
Kinda, yeah. And then you've got your question, you need to design the experiment. AI can help there too, maybe suggesting variables to consider, different setups, or pointing out best practices to make sure it's a fair test.
Okay, experiment done. Data collected. Now, the analysis part. You said earlier that's often where students really struggle, especially with math or interpretation.
Yeah, that's a critical point. AI helps here not necessarily by doing the math for them, but by helping them understand the meaning behind the numbers. Students can ask AI to maybe calculate a rate based on their data, or, and this is cool, model different scenarios.
Model scenarios. Give me an example of that. How does that work?
Okay, so let's use that classic experiment. Dissolving sugar in water. Say a student finds, predictably, that hot water dissolves sugar faster. They could then ask the AI, okay, based on my results, what might happen if I use powdered sugar instead of a cube?
Ah, changing a variable.
Exactly. Or what if I used oil instead of water? The AI can extrapolate from their existing data to make a prediction. This makes the idea of a scientific model much more tangible and connects their specific results to broader principles.
I see. That makes the data feel less static, more dynamic. Powerful. And finally, communication. Wrapping it all up.
Yep. AI can assist with structuring reports, organizing findings for presentations. And the sources also mention specific classroom tools like Khanmigo, that's Khan Academy's AI tutor. It can give step-by-step guidance and explain everything, which is like an AI-powered whiteboard for visualizing experiments and data.
Okay, this range of tools, from research to visualization to communication, it really brings us to what the webinar highlighted as maybe the most important skill now, prompt engineering.
Absolutely.
They talked about that hands-on activity, right? Investigating the sugar dissolving.
Yeah.
The whole thing hinges on asking good questions, evaluating them. That is prompting.
It is, and the core message about prompting was clear. AI is a tool. It just follows instructions. You get generic answers. It's likely because you asked a generic question.
Right. So the skill isn't just knowing stuff anymore. It's learning how to ask the AI the right way to get something valuable back.
Precisely. The key strategies discussed were, 1, give the AI structure, tell it what role to play, give it a template, and 2, crucially, refine your prompts. Don't just take the first answer. Iterate.
Okay, let's make that concrete with the sugar example again. If a student just asks, tell me about sugar dissolving, they get, Wikipedia light. How does refining that prompt connect to scientific thinking?
This is the really clever connection they made. Think of a generic prompt as like a poorly formed hypothesis. It doesn't give you much. When the AI gives a weak response, the advice is change one variable in your prompt and try again.
Ah, okay, like scientific iteration.
Exactly. So instead of tell me about sugar dissolving, the student might refine it to act as a high school chemistry teacher and explain only how water temperature affects the rate of sugar dissolving using analogies related to cooking. See? More specific.
Whoa, okay, hold on. That's it right there. The very act of tweaking the prompt, changing the persona, the constraints, the focus that is modeling how a scientist revises a hypothesis or changes one variable in an experiment to see what happens.
That's the link. By learning good prompt refinement, students are, almost without realizing it, practicing core inquiry skills. They're learning how variables and constraints shape outcomes, whether those outcomes are lines on a graph or paragraphs of text from an AI.
That's really insightful. But it also raises that big challenge that it apparently came up in the chat during the session. How do you balance this? How do you make sure the AI isn't just doing all the thinking for the students?
The million-dollar question, right? And the recommendations were quite practical. Number 1, have students do some initial work without AI. Brainstorm first, maybe write a rough first draft on their own.
Get their own thoughts down first.
Yeah. Then, number 2, use comparison. Have them take their initial thoughts or draft, then ask the AI, and critically compare the two outcomes.
But just comparing isn't enough, is it? How do you make sure they're critically comparing, not just saying, oh, the AI's is better? Do instructors need to guide that critique?
Oh, absolutely. You can't just leave them to it. The emphasis has to be on questioning the AI's output. The experts stressed, embedding critical thinking into every task involving AI. Encourage skepticism.
Skepticism. How so?
Remind them and yourself that these AI models have limitations. They have biases baked into their training data. Their algorithms aren't perfect. So teach students to actively look for those gaps. Where did the AI miss something? Is there a bias here? Did it ignore a real-world constraint? You're teaching them to evaluate the tool itself, not just accept its answer.
Evaluating the tool. I like that framing. Okay, that actually leads perfectly into the next point. We've talked a lot about the student as a scientist, but sources also made this powerful point about the teacher applying the scientific method to their own teaching.
Yes, this was clearly a major takeaway for the educators in the session. The idea is that the scientific method isn't just a topic to teach students, it's a process teachers should use to improve their own practice. There was this great metaphor used. Every lesson is a hypothesis.
Every lesson is a hypothesis, tested by student behavior.
Exactly. Tested by student behavior and then refined based on the evidence you gather from that behavior.
So the teacher literally becomes a researcher in their own classroom, continuously testing ideas about what works best for their students to learn this concept.
Precisely. You observe how students react to something, you design an intervention, maybe a new activity, a different way of explaining. You collect some evidence on how it went, analyze those results, and decide, did my hypothesis, my teaching approach actually work?
Okay, give me a concrete example. What's a teaching variable a teacher might test using this mindset?
Sure. Let's say a teacher hypothesizes that shifting from lecturing about, say, data interpretation to having students work in small groups, analyzing data together with some guiding questions will lead to better understanding, maybe better quiz scores.
Right, the teaching method is the variable.
Exactly. The method of delivery. And AI can potentially help here too, maybe in gathering that evidence, quick comprehension checks via polls, maybe analyzing patterns in student responses faster, allowing the teacher to see if the small group approach, the hypothesis, actually moved the needle and then refine it based on that data.
And didn't the sources mention some customized AI tools?
Mm-hmm.
Things like setting up specific projects in ChatGPT or creating a tutor me persona that could help teachers run these little experiments, almost like creating tailored learning pathways to compare.
Yes. Those tools offer ways to make the classroom more of a data-rich environment for the teacher. It helps them move from just having a hunch about what might work better to actually testing it and using evidence to guide their practice. It speeds up that cycle.
Okay, so let's try to bring this all together for you, the listener.
Mm.
The core idea seems to be that AI can really operationalize the scientific method. It takes these steps that can feel a bit abstract research, hypothesize, analyze, and makes them more concrete, more actionable, with data for both students and teachers.
Absolutely. And that key skill we talked about, prompt refinement, it's not just about talking to a machine. It fundamentally mirrors how scientists revise and improve their hypotheses. So learning to prompt better actually makes you a better inquirer.
So we've seen how AI can boost analysis, make experimentation maybe more accessible, and really sharpen that critical evaluation muscle, pushing learning towards genuine inquiry.
Yeah, it's quite a shift.
And thinking about that evidence-based practice for teachers, the sources mentioned AI potentially running what-if scenarios, like predicting how changing a teaching strategy might impact student outcomes.
Right. That's heading into some interesting territory.
It really is. And it leaves us with a pretty provocative thought for you to consider. If AI gets good enough to help educators scientifically test and maybe even predict the success of their teaching ideas, a new way to give feedback, a different project structure, whatever, before they even try them in the classroom, how much could that change instructional design? What happens when teaching innovations become less of a guess and more like a successful prediction?
That's definitely something to chew on. Where does evidence-based practice go next?
Indeed. A thought for the road. Thanks for joining us for this deep dive. We'll be back next time pulling more practical knowledge out of the noise for you.